Greetings, the Astro 30 here yet again with a brand new video for you. Now, today's video is mostly going to be a planning video of this project that I'm currently going to be doing. I know I've got way too many projects going on. Anyhow, I'm going to build that little 15-watt amplifier module into a rack case. As I said, I did remeasure it. It's actually 15 watts at 35 volt. Which is quite significant. Now, on this circuit board we're looking at here, this is our main power supply, and I tried to keep everything as compact as possible to fit it along the inside of that rack case, because I've only got 400 millimeters roughly from side to side to play with. I'm going to be using a 12012 50VA transformer toroidal, which has a total current across the windings when they're in series of 2 amps, which is more than enough to power the amplifier, 2 modules, and still have about 800 mAh spare. Now, the toroidal will fit inside the case height wise, and it's 85 millimeters in diameter, so everything will just fit. So this power supply here is subject to revision because I haven't actually tested the relay that I'm going to be using with the delay circuitry here to see if it actually works properly, and I don't know what the delay time constant is, so these resistors value here may have to change. I'm not sure if this BC546 is going to work properly as a driver. I may have to change it, I'm not sure yet. I did calculate what the main dropping resistor here is, 560 ohm, 1 watt device, to limit the current going into this relay because the coil resistance is 285 ohms. So that's what I'm going to have to check. I'm using an inline bridge rectifier because it takes up less space, and that's rated at 6 amps, which is more than enough. It shouldn't need to be any higher than that, and that's the bottom because we like looking at bottoms on this channel. So that's the power supply. There's two 2200 microfarad capacitors in parallel here to give us 4,400 microfarad in the end, which should be enough filtration. There's 3 separate output jacks here, 2 for the power amplifiers and 1 for, well, I'm planning on putting a little preamp inside the case just before the volume control, just so the volume control is not spending half of the time up halfway just to get any decent volume out of it. So that's the power supply and muting module. It's not that real fascinating. Let's now look at the next PCB. Right, this is what I'm calling the main PCB. This is the power amplifier section itself, but the output stage is not on the board. Now, I ended up re-including the second variable resistor between the output and the feedback path because I found during testing yesterday that the waveform looked kind of weird on the positive going peaks when it was driving some power output. I'll draw a representation on the whiteboard in just a moment just to show you what the waveform actually looked like. And yes, this does adjust the halfway DC point at this TP1, test point 1 point, to half the supply voltage, but it also corrects the negative feedback, for want of a better term. So that's why I've marked it NFB there for negative feedback. And you may be wondering, why is there a capacitor off here to the left of screen next to the fuse holder? Well, that's the bootstrap capacitor. Unfortunately, when I was routing this yesterday, I forgot to put the bloody thing in. And when I was checking my routing was correct, I'm like, where's the bootstrap capacitor? I'm like, oh, for f***'s sake. Every time I route a PCB, because I don't use auto route, I manually route things, I always end up forgetting one component somewhere. Every single time. Anyhow, that's irrelevant, but as we can see, we've got the bias pot up here and a bunch of connectors. So this connector here is to connect the MPN's base and the PNP transistor's base. The V positive goes to the MPN transistor, the V negative goes to the PNP transistors collectors respectively. The E is the emitter returns. The degeneration resistors for the output stage are on the next board, which I'll show you. And I managed to find a 1000 microfarad 63 volt capacitor online that's only 25 millimeters high. And I think I found some 2200 microfarad capacitors that are only 25 millimeters high too. So they'll barely just fit in the height of the case. So here's our drivers. There's the main input transistor. Zobel network's down here. That's the output capacitor, as I mentioned, the output connector there. And the input down here, as well as the plus 35 and ground. I should really mark that as VCC because the power supply is marked as VCC. But I marked it as plus 35 so we know what voltage we're putting into it. However, what is the maximum that this will run on? I'm going to say at an outside guess 50 volts is as high as you want to take it. I wouldn't take it any higher than that. And you should be able to get probably closer to 50 watts out of it then. And finally, the output stage PCB. As we can see here, we've got, I just realised what I'm missing on my PSU silk screen. That's alright. The transistors all mount from the underside of the PCB up against the heatsink. So the two TO3Ps will be mounted flush with the bottom of the board and up against the heatsink. The screws going through here will mount both the board and the transistors to the heatsink. This BD139 TO126 transistor is going to be slightly floating. So that would have to actually be put in close contact with the heatsink and put a screw in it and then soldered so it's actually, hard up against the heatsink with seal washers, of course. There's a large hole here. It's a roughly 9.4 millimeters in diameter, which should be just big enough to get a screwdriver in there, if not a pair of small needle nose pliers to do up a nut. The thing is roughly 75 millimeters wide by 33 high. That'll just fit inside a 75 millimeter heatsink by 105 millimeter heatsink. And you'll be probably saying to yourself, well, Astro, isn't that heatsink underrated for the job? Well, kind of. See, the thing is though, the heatsink will be put into direct contact with the bottom of the case, facing upwards, and the actual bottom of the case is aluminium. So it'll act as a heat spreader, and the whole case, in effect, will act as a heatsink. So there should be enough heat dissipation there. I mean, it's not going to be sitting there operating at full power all the time, so it's not going to get remotely that hot. But that remains to be seen. But that's my design. That's how I've figured it out. And as you can see, you've got this connector here, which has the B plus and the B minus for the PNP and MPN transistor respectively. The voltage is in and out for the output stage, and our VBE multiplier connection here, which goes back to this transistor. I've marked all the emitters, collectors and bases on the silk screen side, so we know that when the transistors are mounted on the underside, what orientation they are and where each particular pin is. So yeah, that's it for the circuitry. I haven't had any of these made yet. They're still subject to change yet, but that's the plan. Now I'm going to move on to something else, and that's how weird the waveform looked on the screen, hence why I've put that 1 megaohm pot in there. I found it needed to be 1 megaohm because 50k, 100k is too low. The feedback resistance, when I actually corrected these peaks, and yes, I know they look like a pair of tits, but the total resistance from the 470k's perspective turned out to be something like 640k. So we had a nice symmetrical waveform. But yeah, that's what I was getting on the screen until I played with the feedback. And yeah, that's what the trim pot's purpose is for. So Jeff actually sent me a bunch of shit for that ESP project number 101. Some speaker connectors and some isolating stuff for RCA sockets. I'm not sure what these nylon things are, but they seem to fit okay on these speaker jacks, banana jacks, whatever you want to call them. This is mine. These RCA sockets are mine. This is the weird power switch that he sent me with a piece of heat shrink over the normally closed connection on the AC, which is fine. This can handle up to 3 amps, so it should be fine for this project. And it's a blue illumination. And it has 12 volts, but I'm not sure why there's 3 pins for it. So this is kind of confusing. Oh, hang on, I think I see. This is a DP-T switch. I reckon this is also another AC connection here. And these two here are for the LED. This is a really convoluted looking switch too. So yeah, that's why it has positive and negative in the middle of the moulding here. Now, interestingly, this fuse holder apparently, according to the JCar catalogue, is not suitable for 250 volt AC, but it does say on the casing here, 16 amps, 250 volt. But they reckon it's not suitable for AC. The only issue is that, yeah, you've got 3 pins on this thing. So this can be inherently dangerous to come into contact with, but put a piece of big heat shrink over the top of that once you've soldered all your wires to it, and yeah, end of problem. And I've used those ones before and hadn't had a problem. Also, this case, I've realised, is assembled upside down. In other words, the top and bottom panels are inversed, because if I look at the side of the case, see those extra holes there at the top? Well, that's actually supposed to be at the bottom, because that's where the extra rails that this case was supposed to come with, but it only comes with 4, to allow you to mount the rails across inside the case so you can mount PCBs on them. But if you guys remember when I was doing that sub-bass project, I had to go back and forth the JCar 3 times in order to get all the components required to assemble the case. So I think the first time I was missing the front panel, so I went back and changed it. The second time it was missing the sub panel and the rear panel. And the third time I went back was when it was corrected, and I ended up with 4 of these rear panels and sub panels, which is handy. But there's still only 4 rails. I think at one point the rails were missing, or something was missing. I know the front panel was missing on one trip, and the rails were missing on the second. Or the sides were missing, or the handles were missing. Something was missing, I can't remember. Anyway, so that's what I plan to do, is drill a bunch of holes in the back. That's what I'm going to work on today, to mount all these components. Now, before I start marking and drilling things, I've added a short piece of heat shrink to either bottom-most part of the thread of these RCA sockets, so that the threads are insulated when it's going through the hole in the panel, so it doesn't come into contact with it, because I want all the earths floating from the panel, from the outside world, and actually earthed at a star point in the inside of the case. That is the theory anyway. How well that works, I don't know, because there are screw threaded parts sticking up on either panel and either side of the case to mount earthing points to. See, there's the stud there. Now, in the case of this, this might be an issue when I want to mount the transformer. This might have to be ground off on both the top and bottom covers in order to make the fitment work. But there are studded ones on either side of the sides here, so I still got a grounding point. I have to figure out what size thread that is. I think it's an M5. So as we can see, that's also got a stud on the top panel, but I just want to find out what I've got to work with. I've got, if I can get the measuring tape to agree with me, I have got 394 millimeters to work with, but I'm going to be missing 10 mil either side to accommodate for the lip that this panel screws to. So that would mean I now have only 375 millimeters to work with to fit everything in. So I have to do a quick calculation. 357 millimeters, it will barely fit, so yes, that stud will have to be cut off. So how I worked that out is I took two heat sinks, 75 plus 75 is 150, plus the width of each of the power amp modules, which is 34, so that's 68, plus 68, plus the width of my power supply module, which is roughly 54, equals that, plus the diameter of the transformer. Yeah, and I have 375 to work with total, and I've got 357, so I've barely got any room. But it will fit, albeit the heat sinks will have to be mounted as close to the edge here as possible. A power amp module, another heat sink, power amplifier module, power supply, and my little adapter thing to connect the AC line cord to the transformer, and finally the transformer. So these will have to be ground off, both top and bottom. But that's not a real great issue at this point. So anyway, I'll take the bottom off now and I'll start marking out the rear panel ready for drilling. Okay, I got everything marked out. I made a mistake, but I corrected it. Got the left and right inputs coming in over here. The 4 holes for the speaker terminals. The fuse over here, it doesn't all quite fit on frame, plus the power cord coming in here. Okay, so now I need to center punch those and drill them out, pilot holes, and then size them up to the final size. Pilot holes are drilled without too much effort, and I didn't drill through my fingers either. With this power connection, I'm going to drill it out to probably 8 mil and leave it there, because I'm probably going to have to either resize it or file it out to put the cable clamp in that I'm going to be using. If it will fit within the 20 millimeters that I've got between these two frickin' rails, but yeah, we'll see what happens. I should really check wherever my fuse holder is. There it is. Yeah, that should fit between the rails. Oh yeah, plenty of room. Okay, now to drill those holes out to the correct sizes, apart from the power one. All the holes are drilled and deburred. This is the inside edge, by the way. So now all I've got to do is start mounting components into the holes. And those isolators fit just nicely, although I've got a bit of plastic, that's alright. So I'll mount the speaker terminals first, and then I'll show you what I've got. Okay, I've run into my first problem. I can't crank these nuts down without deforming the washer, so I'm going to have to come up with a different alternative or find replacement sockets for that. What a pain in the ass. Everything else is mounted though. Got the input socket, fuse holder, so I might put this back on the case and just stare at it for a while. Hey, you, fat f***. Seriously, I've got the panel screwed back on. I've also screwed the bottom panel back on, just so it doesn't freak out on the asteroid. Wait, what? Never mind. It's a shame about these connectors. Well, it's not over till the fat lady sings, as they say. And no, I'm not a lady, nor am I going to sing. Well, what did you expect? Anyway, I was thinking on my way to work this afternoon, and I popped into J-Car, and I got hold of these HP0166 M4 nylon washers. And I'm wondering if they'll fit over the shaft of the thing here and not pass through the hole, as well as insulate it. It's a pretty big hole, so it doesn't matter, like, as long as you get it roughly central, it's not going to short on anything. There is a bit of a divot here though that I've got to be careful of. Anyway, let's try one. Well, it fits over the thread. Doesn't pass through the hole. That little divot makes it look ugly though. Anyway. I think that might just work. I'm going to use a screwdriver to hold that square, I suppose would be a word for it. Well, it's deforming the first washer. I guess that's fine. Well, I think that worked. Yep, that worked nicely. Cool. Alright, let me just do the other three and I'll come back with the results. Check it out. It looks all good. Yes, the terminals are a little bit crooked, but it doesn't really matter at the end of the day as long as it's functional. And that they're isolated from each other. Apparently. And they're continuous to itself, so as long as it's not shorted to the case in any way, bingo. These should be isolated too. Indeed they are, except from themselves. Cool. And just before I go, I've actually used the isolators for what their correct purpose is, which is for the RCA sockets. Looks a little bit neater than those ugly brown reddish things that were on the outside before. Same size hole anyway as the sockets, so it snapped right in. And so the only thing is you just cannot get the spring washer on, but you don't probably really need it considering if you can squash that down enough. And the surface area of the tag is wide enough to stop it from going into the inside of those isolators. I'm going to leave this video here because it's going on for a million years. Well, probably not quite that long, but this is only just an introduction to what I'm planning on doing and my thought process behind the planning. I know I've got like several other projects on the go at the moment, but I wanted just a simple cheap one to, you know, be going on with in the meantime. So anyway, if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook, and you can become a Patreon member for as little as $1 a month. Anyway, this is the Astro 30 saying see ya, have a great day.